Jim has sent in a BC1000 battery charger. He has a few questions here. He wants to know what the purple and white wires do, which output wire is positive and negative, and most importantly, does it work? So yeah, got it's an old BC1000 here. I've fixed a few of these before. I think there's 2 or 3 of them on the website already. You usually have output stage problems, or I think one actually had to rewind a transformer. So, interesting thing is we have a old RMA number on here. Don't know if this is from Solectria or not, but 63 of 98. That's probably not a good sign. Serial number does match. It is 1243, which would be awesome if it was 1234, just for the heck of it. Came with temperature sensor, which is always good. Don't have to fake that out. For the polarity on that, this is the output. Green is ground, white is positive. Don't know why they didn't use red and black, but they're using some kind of, yeah, I don't know. Green and white. Green is ground, white is positive. And then on this connector, I'm trying to remember, I think 2 of the contacts get shorted together to tell you that it's plugged in, and 2 of the contacts get shorted together to tell you when the charge is complete, I believe. I don't remember which is which. I will have to do some research and or look it up to see what about that. Not quite sure. But first thing we should do is probably check the fuse. Grab my meter. Because if you watched the last video, the fuse is blown and it doesn't work. I actually tried hooking up power to it momentarily and it just pops. It's not good. But this fuse is good. So we're already 1 step farther. So let me double check what my pack is set to. I believe it's set to 144 volts. This is a 140 volt charger. It's 1 kilowatt, 7 amps. I like how somebody wrote 144 DC with exclamation points that already said it. Let's see what the old what the pack is currently set to. I believe it's got to 144. Or thereabouts. And we're at 143.7, so battery's okay. I really need to build a big variable power supply so I don't have to have this big battery pack hooked up. It's kind of dangerous. But in the meantime, we can actually hook it up here. So we'll go ahead and plug this in. Again, I really need to just do something better with how dangerous a lot of this is, but that'll work. There's probably going to be a little bit of a spark when I plug this in, because there's a bulk cap in here and there's no kind of a inrush current limiter for it, so get ready for a little spark. Yeah, not too bad. So I got that plugged in. Go ahead and hook up the hyper terminal here. We set it for 3800 8N1, so pretty standard setting. And there's a little port here on the side. So I got that plugged in, and we could probably, well, we'll just see what it does and then I can measure it if it's actually charging or not. Just use this to keep everything in place. got the temp sensor hooked up. And we'll go ahead and I've got power here. See what she does. It's nice that the sump pump turned off, so it's nice and quiet, so you can hear anything going wrong. You ready, set, go. Nothing. I didn't get anything, nothing came up on hyperterminal. And definitely does not sound like it's actually doing anything. Double check what the pack voltage is still at. I can get in here. Maybe we'll get this way. 143.6, so we're obviously not charging. And maybe we blew the fuse. Oh, we can check one thing though. Remember, some of these contacts should do something. Okay, so these ones are open. So the two purple ones, if I unplug it, yeah, okay. So the two purple ones, when it's plugged in, that tells you that it's actually plugged in or not. So that part's at least working. I think there's a little relay that just clicks in when it's plugged in. That means the white set is for when the battery is fully charged. Then those ones close when it's done charging. So there you go, Jim. The two purple ones are your motion interlock. So when it's plugged in, that'll keep the vehicle from moving. Okay, so yeah, we're not getting anything at all. Nothing. Alright, well, that was a quick check. So the does it work? Is no, it has something wrong with it. I have to take it apart. What's interesting is the fan didn't even spin up, which is it even click it freely spins. Oh, it's humming now. Is it actually doing something? I don't know if you can hear it on the video, but it's humming. It sounds like it's trying to do something. I hear bad stuff. We're gonna turn that off. It has magical smoke has started coming out of something. Yeah. Now it really doesn't work. It is yeah, it's got some magical smoke smell going on there. I'm gonna guess part of the output stage is dead. Yeah. The fact that it was humming means that the transformer was working really hard, and I think it's dumping into a load that's completely shorted. At least to a point, because I was able to hook the battery pack up and it didn't pop the fuse on it, so I only have a 10 amp fuse on the battery pack. So, yeah, I guess, 9 minutes in here, I could probably just open it up. So, of course, man, that is not a good smell. Well, at least we'll know something that died, right? So I'm going to discharge this, because I had the pack hooked up to it. It is technically in an unsafe point here, so what we're going to do is, I got all these little resistors will just bleed off the pack or the output stage here. So it doesn't, I mean, it's only 144 volts, but you know, safety first, right? So, let's see what that does. And then, and if you wanted to know, that's a 1.8K resistor, 7 watts. If I get my meter again, I can check it. And it's dead. See? Discharged. So yeah, let's go ahead and take a quick look inside and see how bad it is. One thing that's interesting is the hyper terminal never ever came up with anything, so I don't know if the processors, I don't know, it's hard to speculate. The fact that these are all loose, and somebody's probably opened this up before. there's like a good smell coming from it. It's definitely seen better days. Gosh, it's one thing about that magical smoke. Oh, well, that's why the fan's not running. It's not hooked up. Interesting. I'm gonna say, this is because the fan is just like a straight AC fan. Like once it's plugged in, it just turns on. Well, maybe there's a that might be one of the relays turning on and off. Okay, so let's see. Move this out of the way here. Let's see what we got here. I'm gonna guess that this diode down here is dead, because that doesn't look healthy. Let's see what else. I'll have to go back and look at the pictures for the other ones to see if this is supposed to be populated. If we're missing a prom, that would be bad, because I don't think I'd have a copy of the code to go in it. But that might be normal. I'm just doing a visual inspection to see if anything else looks completely dead. But I'm not seeing anything other than I'm thinking some of these diodes down here are dead. That's what it looks like anyway. Yeah, that guy was warm. This is really warm. And that's really warm. And it's all warm. It's all in the same heatsink. So, yeah. What we need to do is I'm going to take this board out so I can check. I might be able to diode check those guys while they're in there. But I'm guessing one of these diodes over here is bad, because one looks pretty smoked. I guess we could always hook it back up. Can you see down in here? I'm thinking it's this guy right here. See? It's kind kind of don't really have a good angle on the camera, do I? Not taking that out. What would it take to take that out? Looks like I got 6 screws and then these. Might be able to flip the whole thing up. Kind of hard to get in there though. Let me see if I can prop that up. Oh, I can't. Okay. No. It's not heavy enough. I feel like this. Let's see if I get the angle right so we can see down in there. Well, kind of, sort of. Yeah, the sub pump's running a lot because it's raining right now. It's doing its job. So we want diode check. And we're going to go down in here. And we're going to see if any of these guys are alive. I don't think I'll be able to get it. Oh, well, that's dead shorted. That one's not good. Yeah, these guys are the problem. I can't get down in there, not enough room. That's me hitting the probe. I can't. Oh, wait, maybe. I can't get an angle. Oh, wait. Nope, can't get a good angle of that one either. This one I can get on. Yeah, he's dead. They're all dead, Jim. Oh, I can actually say that because this is Jim, so I can say it's dead, Jim. Yeah, those are dead. That or this big cap out here. This is the output cap. Nope, it's not dead. So, yeah, all those diodes are dead. I've met an untimely end. I see somebody's done some kind of repair down here at some point. There's an extra wire soldered in there. I don't think it's supposed to be there. So, the question is... It's like a spider or something. So, yeah. If the entire output stage is dead, and that's what I mean, this thing's really simple. It's just a forward converter. Then they do a bridge rectifier, inductor, output cap. So this is the entire output stage. It's pretty simple. And then feedback. Those are around in here somewhere. And these are all the little gate drivers. These are the gate transformers that fire these MOSFETs over here. There might be IGBTs. I'd have to actually take one out and look at it and see what the number is on. But these are all the bridge rectifier diodes. There's 5. They do something weird. It's a full wave bridge rectifier for the output, and then they have a diode across the center for when this is not transferring energy, then that cuts off so normally you'd have to go through 2 diodes, so they go through 1 diode and it freewheels through this inductor current gets freewheeled through that middle diode. I can draw a picture of it really quick. If I can find a pen, here you go. But yeah, it looks like those diodes are dead. I have to swap them out, but this is what I mean. They have essentially a bridge rectifier, right? So you're going to have your output from your coil. So there you got your transformer, right? It's going to come over here like that, and then you're going to come off of these points. This will be your battery, like that. And so the easy way to do it is I always go like this. You draw on your diode, right? Because you want power to come out that way. And then if power to come out that way, it's got to come back this way, right? So so your coil will go that way. And then when it's the opposite direction, we want power to still go this direction. So you got that diode, and then power come back this way. And you want you always want it to return. Now I got messed up. Hold on. This is why I shouldn't do things live. It goes out. So if it's going this way, it goes that. Yeah. If I go this way, I'm still pumping this way. I want this to go that way. So there's your bridge rectifier, right? And then they've also got that big inductor is in here too. So we'll draw that in here. So that's that big coil that was there that I pointed out. And then this whole output here gets this cap here. And that's what you end up with. And then that fifth diode that I'm talking about, they put right here. So that's why there's 5 in it. And what that does is when this, when you're not firing this, there's still energy stored in this inductor, and so that'll pump energy into your battery pack, and then it goes through this diode here, because there's not a path. Well, there is a path. You'd have to go through 2 diodes in order to do it. So this allows them to save a bit of energy by doing that. So when it's running, it's usually toggling this back and forth. Like I said, it's just a forward converter, and with a full wave bridge. And then these parts are literally pretty simple. That cap is right here. This inductor is right here. This bridge is this whole unit down here, and that's why there's 5. And then this is this transformer right here. Everything else is measuring voltage, measuring current. And it does have a current sense. That's this big resistor down here. I don't know if you can see that. There's a big 0.015 ohm resistor down here. That's the current sense resistor. And that's all it's doing. It's measuring current there, and measures the voltage somewhere up in here. I'd have to... there should be... It might not even be isolated now that I think about it. I think it is. Try and find. Normally you'll see a big optocoupler somewhere, but I'm not seeing it. This is all the gate driver circuitry, and these are all the FETs. And I believe it is. I'm trying to remember if this is a push-pull topology. Because there's 6, but I think that's because there's 3 in parallel and 3 in parallel, and it's actually I have to draw the rest of it here. Yeah. I think this is actually center tapped, and then they're doing a push-pull where this is connected to bridge rectified. So right here, this is the input bridge rectifier, and so it's going to get a little crunch in there. So just imagine there's another one of these, but for the 120 volt AC input. Well, I guess I could draw it really quick. So we'll do this. This pen is like dying. So it's exactly the same thing. So we're going to have AC coming in here. that's an AC plug, right? Sure, trust me. And then we're gonna get out of here, same kind of thing. You got ground. We're gonna have 180 volts because that's about what it's. 120 times 1.414 is approximately equal to 180 volts. And then we're going to have a bunch of caps to ground. That's all these guys right here. All the big, that's the bulk cap that's been, and then this is the same way. So I've got a bridge in here. And draw my diodes really quick. Right, so you got a bridge rectifier, you got that. And then this, I probably could, so this is the same point here. And then I believe that this just has, I'll just draw one, but there's actually 3 of these MOSFETs. And then it's the exact same thing again, so I'll draw it over here. Those would be N channel, and like that. And then what it's doing is all that circuitry over here. That's the gate drivers, and they're just sitting there doing this. And it's going to turn this guy on, so I'll take this energy, run it through this one, and then that induces a magnetic field on this side, and then it will turn him off and then turn the next guy on, which will run energy through the opposite direction. And essentially it's doing a push-pull on the primary. Secondary does a full bridge, and then it's got a voltage sense out here, it goes back, and it's got, there's a resistor right here, that's that, what is it, 0.015 ohm resistor, and then they're coming off of that with a op amp of some form. Probably look and find it. And then that's going back to the micro. And then out here there's going to be a big bunch of resistors, voltage divider, right? And they're going to do the same thing. This pen is completely dead. And then that's also going to go back to the micro. So that gives you your voltage feedback and your current. And there you go. That's the whole battery charger. There's not much to it. And then this little circuit board on the side here is just an off-the-shelf 120 volt to 12 volts or 12 volt and 5 volt or whatever supplies that the rest of the thing needs. And yeah, that's about it. And the micro just runs its little VI curve for the batteries, and that's it. There's not much to it. Everything else is just op amps, and there's a few little resistors down here, and some snubber caps, snubber cap and resistors. And yeah, that's it. And then a few little relays to do that it's plugged in and when it's fully charged. Yeah, that's it. Pretty simple. But yeah, there's definitely something shorted out there. So I'm going to have to take that apart. I'm going to have to email Jim and see what he wants me to do with these. I still have a motor controller in there. I think it's a AMC 325, also in the same box. And probably take a look at that one if I can get it out of the box. It's pretty heavy. I have to enlist the wife to help lift it out of the box. It's pretty heavy. Still having issues lifting heavy things. But yeah, that's the schematic, very crudely drawn with a bad pen. There you go. Anyways, hopefully it was informative and you learned something. But yeah, thanks for watching.